Hi friends, welcome to our new video. Welcome to Tanu Tech World. And today we are back. I'm going to explain to you that how 2 HP solar submersible pump works. So we have installed this. We have installed. This is the VFD or variable frequency drive control panel of the 2 HP solar submersible pump. So the site here, you can see the site is at Purulia, West Bengal. So this is at a hospital which is called Swami Lokeshwarananda Eye Foundation. So this is an eye hospital. It's located at a remote location at Purulia. It's called Para. The area is Para. So here we have installed this system. As you can see, the submersible pump is over there. You can just see, and I'll show it to you later. And from the submersible pump, we are drawing water to overhead tank, which we have a capacity of 4,500 liters. So this we have installed in here, and the depth that the submersible pump goes is about 100 feet below the ground. So the bore right now which is there is 120 feet, and this is the bore length, and the pump is installed at 100 feet below the ground. So it's drawing, but water we have got around 70 feet below ground, but we have kept the pump at 100 feet, so that in case of any drawdown, if any drawdown occurs, so that's not a problem. So water can go down, but still the pump will operate. So let me show you the working of the pump. So this is the VFD or the variable frequency drive. This is the control panel. So here we have taken it from Amrut. As you can see, solar pump DC controller. This is it here, and this you can see I'm opening the panel. So it's written here that what is the pump. This is a 2 HP pump, and this is a controller, and the pump works at 160 volts. So you need to have a minimum of 160 volts at the DC side also to make this pump work. If it's lower than that, so it will not work. So let me walk you through all the components which are there. So first you see, this is the DC MCB. This is the 500 volt 16 ampere DC MCB, which is controlling the DC. So the DC is coming. So this is the DC line. This is the 4 square mm DC line, and we have installed a 2 kilowatt system. I'll show you later. The 2 kilowatt system is installed to operate this 2 HP solar pump. So the DC line is coming through here, and the DC power is going to the MCB. And from this MCB, we are controlling that whether we want to turn the DC on or DC off. And another very good thing about the pump is that it operates on both AC and DC. So you can operate it either from solar panels and also from conventional grid supply. So this is one added advantage. So here is the DC MCB. So here you can see here written that motor IP. So first you can see power, so solar panel input output, which is this one, plus minus, which is given PV plus and PV minus, which means solar panel plus and solar panel minus. After that, motor input. So you have 3 phases here, UVW. You need to connect 3 phases of the pump. So this is going to the pump, 2 HP pump. This is going to that. And after that, you can connect the grid also. So you can connect the live and the neutral. So single phase also you can connect, so no problem. And another, you have the earth, E. So this is the connection, and this is the fuse. So nothing to worry about it. And this is the main VFD controller. So this is also provided by Amrut. So this is the VFD controller. This is the frequency at which the pump is operating right now. So I can also bring it to voltage and ampere what the pump is drawing. So currently it is at hertz, as you can see, frequency, and it's drawing about this much it is drawing. So as the solar intensity or the irradiation changes, solar insolation changes, and the power also changes, the maximum power that the solar can deliver also changes, and as a result the pump capacity and the pump output capacity also changes. So but if you have grid, if you have it connected to the grid, so that's no problem, it will work constantly at a certain fixed frequency. So here I'll show you how to control this. So first this is the solar mode. 1 is the solar mode, and 2 is here, I think. Yes, 2 is the grid mode. So grid is not connected, not our concern. So you can see we have turned it on, and you can turn it off also. So and you can select either if you want to power it through grid or you want to power it through solar or grid. So here is the control. So I'll just show you. First it's on, then you can turn it off also. So you see frequencies gradually falling. So it's not falling like all of a sudden, it's gradually falling. Why is that? Because if I want to put the frequency down at a single moment, the pump will not operate, the pump will incur some damage. So we want to gradually rise the frequency, increase the frequency, and gradually decrease the frequency when we turn it off. So this one is for solar because we don't have grid. I'm turning the pump on, and you can see the water will be coming through that outlet. So you can see gradually the frequency is increasing, not at a few moments or momentarily or within a pulse of time it's increasing. Gradually we are increasing it at an incremental, very small incremental rate. So here it's fixed at 41 Hertz right now. It's varying because solar intensity is varying. Right now solar intensity is less, frequency is also. So this is how it works. And now we'll show you the output water capacity and the solar panel. 2 kilowatt solar panel PV setup. So we have a 2 kilowatt system here, 2 kilowatt peak. So it will generate about 2 kilowatt at the peak when sunshine is at peak. So this is what is powering our solar submersible pump. So for installing this 2 kilowatt system, we have procured about 6 335 watt peak solar PV panels. So as you can see, these are made by Amrut Energy, and this is the electrical parameters of the PV panel. Each of the panel is of 335 watt peak, and we have connected 6 of these solar panels in series. So as you can see, these are the 2 connectors that goes positive and negative from the solar panel. You can see positive and negative is marked over here, and we have to connect all the panels in series. As you can see, these are connected by this MC4 connectors, and after connecting we have 2 terminals arising out of our system, which is positive and negative, which goes into the VFD as we have shown. And in order to make the installation more robust, we have installed a small pedestal. This is a foundation which we have to do in all the solar PV panel setups, so that due to wind or any other natural calamities, storms and other things, the panel does not get damaged. So people are also working over here. As you can see, the positive and negative output from these panels, which are in series, is going through this cable routing, and it's being diverted or routed into the VFD. This is being routed in VFD, and you can see water is now, that is the submersible pump, and which is now right. So as the solar irradiance gradually fluctuates, the output water delivery rate also fluctuates according to that. So when the solar irradiance is less, the frequency of the VFD also becomes low, and when the solar irradiance is optimal, so the output frequency of the VFD ranges from 40 to 50 Hz. So thank you for watching. We'll meet in our next video, and I will show you something interesting.